We can get going. My name is Bill Keener, and I'm with the Golden Gate Cetacean Research. And we've been looking at the return of the harbor porpoise into San Francisco Bay, among other things. There's a couple other things we're going to hit on in my talk today. And so I've got a bunch of slides, and go ahead if you've got questions, just ask me, and we'll leave time for more questions at the end. And let me tell you a little bit about myself. I was at the Marine Mammal Center back in the 1970s. So I was the director of the Marine Mammal Center actually in the early 80s for a couple of years. And I also was doing whale watch naturalist duties for the Oceanic Society. And there when the sanctuary started, and one of the first things the sanctuary did was they wanted to know, get baseline data on animals in the sanctuary, and they were interested in harbor porpoise. So I was involved in a study in the 1980s for 3 years where we went out many, many times into the sanctuary to look for harbor porpoise and count them and try to do a photo ID of individual animals, which was a failure. But we were able to count, and so we got some information about that, and I'll mention that a little bit more when I show you the slides. So I've been involved in marine issues, marine mammal issues for a long time, and I sort of had a love-hate relationship with harbor porpoises in the sense they're the toughest little guys to see and get to know well. They're really hard to study because they're just so timid. They don't approach boats, they flee. And so when we started seeing them a few years ago, really in 2008 was when we got really started on this project. Looking at them from shore, right here in San Francisco and Marin County coast, as they came in and out through the gate, we got a few people. We got a professor at San Francisco State, John Stern. Izzy Sejapanic has been working on harbor porpoise longer than anybody here in the Bay Area since the 70s. He did his master's thesis on harbor porpoise. And another fellow, Mark Weber, he used to be with the Marine Mammal Center, who's now with the U.S. Fish and Wildlife Service. And so we all founded this little research group just to really study these guys intensely and see what we could learn. And it's been a really, really fun and amazing last few years. So this is what we're. So I don't know if I guess it's that the light coming in from that door. Can you guys see this okay? I didn't realize it would be quite so bright on the screen, but you guys can see it okay. Thanks, Michelle. Anyway, so this is what we started seeing, and there certainly had been, during the years that when I was with the Marine Mammal Center and with the Oceanic Society, we weren't seeing any porpoises at all in the bay. I mean, for years we'd go by, we would have 0 sightings. And so this is pretty amazing. Here's our Russian Orthodox porpoise here. And so this is what these guys look like if you were to draw them or suspend them out of water. So they're about 5 feet long, about 100, 150 pounds. They have a very short lifespan for cetacean, probably the shortest of any cetacean, maybe 10 or 12 years is average. They found females before that they've estimated their age at 20 to 22 years old. From England, they've had one on the East Coast, but that's very rare. And usually 10, 12, 13 years, something like that, is pretty much an average lifespan. So it doesn't give them a lot of time to, have lots of calves and stuff. So it's one of the things about their biology that's really interesting from cetaceans.
Does that scientific name mean that it's its own species and its own genus?
Well, right. Yeah, exactly. There's about 6 porpoises species in the world, and then there is many more dolphin species. So dolphins and porpoises are all in sort of one family, but these more coastal animals that have a very blunt nose, they have little spade-shaped teeth. There's some other, differences. And of course, we have an expert here about some of these animals, but that's about right. So we've got the porpoises, which we've got another porpoise species that lives here is the Dahl's porpoise, which is offshore. Phocinoides dahl, it's not in the same, but yeah, it's just got its own genus and species. So we've got a subspecies here. But.
Is that the only species in the genus?
Casina sinus is the vaquita, which is in the northern Baja, the Gulf of California. so here's the differences between dolphins and porpoises. And people often ask, and I think it's worth noting where these words come from because it's confusing, and it's true that even the marine mammalogists contributed to confusion because years ago, even 20 years ago, I could read papers, and they're calling dolphins porpoises and porpoises dolphins, and it's just all mixed up. And the reason it's mixed up is because the dolphin is just the word from Greek for that word of this kind of animal, a dolphin. Whereas porpoise is the Latin, and it means pigfish, porcus piscis. Pigfish is because they're kind of fat and stubby, and they have little piggy eyes when they look at you. And I guess that's the way they looked to the ancients. And you can really see these differences, and we're going to talk more because we've also bottlenose dolphins in San Francisco Bay, which I'll show you some photos of as well. And you can really see the difference in this dorsal fin, this really tall, curved dorsal fin, and the front beak. Yes.
So, I said something, but I'm not sure if it's true. The fin seems more like a shark fin than a triangle as opposed to a bush.
Well, which do you think is more sharky?
The porpoise.
The porpoise? I guess so. But, I don't see that many shark fins out in the bay. What do you think?
You can get some pretty tall shark fins. Even the white shark fin is higher. The harbor porpoise dorsal fin is more of a triangular shape and small.
Right.
So that's
Pretty
what
small.
stands
The
out.
shark isn't as
The
big.
shark can be longer and falcate, which means curved.
Right. This falcate is this curved falx from the same word as falcon, meaning sickle shape. So the one thing that when you see these guys, you don't really confuse them with sharks because they roll at the surface, very unlike a shark. Okay, so this is their range map of their worldwide range. So these guys are in same point conception where it's hard to see them, but at least when you get up, by the time you get into Monterey Bay, you're definitely seeing plenty of harbor porpoise. They go all the way up to Alaska, around to Japan, and then there is the Atlantic ones from, say, New York, New Jersey, up north into Canada, and then you've got some around Iceland, and all into Europe, and then they've got a Black Sea subspecies, Phocina relicta, which is in the Black Sea. So these guys have different things going on in different parts of the range. In Europe, their numbers are well down. They used to be in the English Channel, for instance, and now they're just really hardly seen. They're rare there. In the Black Sea, they're not doing particularly well either. In Denmark and Germany, those areas in the Baltic, their numbers are way down, and they're endangered there. So, but they're doing actually pretty well along our coast. And you can see these kinds of numbers here. Oregon, Washington, 37,000. San Francisco Russian River is our little local stock that the National Marine Fisheries Service specifically calls out and sets aside and describes. So there's about 10,000 between the San Francisco Russian River area along our coast. And so I talk about a return of them, so how do we know they were here in the first place? Well, we know because there's zooarchaeological evidence from shell mounds, and we've got reports from whalers. Captain Scammon was in San Francisco Bay in the 1870s, and he noticed some of these porpoises were being caught in the seines of the Italian fishermen who were out fishing in San Francisco Bay. And then there's 20th century reports. We know that I talked to the family that runs the Angel Island Tiburon Ferry, and the guy who founded it was born in 1915, and he remembers being 10 years old, 10, 11, 12 years old, and he could walk at the dock in Tiburon, which was just a railroad town then, and he could hear them breathing at night, puffing. And that's one of the old names that sailors gave to these guys, is puffing pig, because you could hear that little expiration.
I've heard of Scammon's Lagoon.
Right, same guy, Captain Charles Scammon, who figured out how to whale for the gray whales off the Mexican lagoons. Well, he was up along this part of the coast too, and that's when he saw or knew about harbor porpoise in San Francisco Bay. So a lot of people don't know how massive these shell mounds were in Emeryville, but they were like 50, 40 feet high, some of these things. And they were all ringing the bay when Europeans arrived, and they tore them up because they wanted to develop the area, or they wanted to use all the shells, the millions of shells, oyster shells and stuff that the natives used, would pile up, and they used them for lime for mortar. the studies have done on these skeletal remains, they show there's small numbers of dolphin and harbor porpoise throughout. So somehow these natives were able to get a hold of some of these guys in small numbers. I don't know how they hunted them or whether they were just catching ones that were stranded or not, but that was in the bay. So what are some reasons why they might have disappeared? Well, one thing that we are thinking about is the submarine net that was put in place all across the bay at the beginning of World War II. Of course, there was a huge amount of military ship traffic that all started suddenly. I mean, I think the bay, it's hard for us to understand how different the bay was physically in this aspect. So it was noisy. There was all kinds of water pollution. They were building the Liberty ships in Richmond and in Marine City, in Marin County. And so there's all kinds of industrial and municipal pollution and sewage going into the bay, pretty much unchecked at that time. And here is a picture of what it looked like. I can use this little laser pointer here. So here was the submarine net. So from about here, all the way across the Sausalito was very long, and it was complete. That steel cage that I showed you before is a 4-foot square net. It went from absolute top all the way to the bottom. It was anchored with huge concrete blocks on the bottom. And so that would have been a very effective fence to keep out porpoises. In addition, they had mines all ringing the gate and across here. Every single time a ship or a boat would have to come in to San Francisco Bay, they had to have a Navy tender open a little door at the top of the net and let them in and close it behind them. So it was a pretty amazing operation. And so that would definitely have affected marine mammals, at least the cetaceans. Okay, so when I talked about working for the National Marine, for the Gulf of Fairlands National Marine Sanctuary back in the 1980s, these are the plots of all the places we saw. So here's San Francisco, all the plots where we saw harbor porpoises in that era. And so we counted about, counted about 2,100 animals. And so there was lots off Point Reyes and lots off Marin County and a bunch off San Mateo County. And then as it gets deeper, waters out towards southeast Farallon Islands, there was many, many less of them. But we crossed from inside the bay to get to our study area many, many times over the streets. We counted 0 in San Francisco Bay during those 3 years. And we were looking for them, and that was our study. We also tried to get close to them to be able to photo identify them. We were unable to. We got a few photos. It's back in the old days before digital photography, plus these animals are just fleeing the boat, and so it just really didn't work. What we've done recently is we've set up, we've got a permit from the National Marine Fisheries Service to closely approach dolphins and porpoises in the bay so we can take photos. And so this is our study areas that we've set up. But basically, we're just really dealing with our Zone 1, which is the central Bay Area. We haven't really done much work down in the South Bay. We don't think there's a lot of porpoise sightings down there. I mean, I'm hearing from a few that are just right sort of other side of the Bay Bridge. And we know there's some hanging around Buena Island. We know there's a few in the northern zone. And I've heard of a couple of sightings in the Carquinez Straits. And then one, I got an email from a guy who said he saw 2 up in Sacramento a couple of months ago. And I was talking to Sarah Allen about this, who's written the book on California marine mammals. And he said it doesn't shock you that much. I mean, these guys, they'll go exploring and they'll go looking for food, so they'll end up at the farthest end of where the water system will take them, and that's Sacramento, or I guess we haven't had any Stockton ones yet.
So are they able to handle fresh water?
They are for a while, yeah. If they're just looking for fish, they'll be fine for a while, yeah. I mean, we've had those humpbacks, that were up that far, and that was a while. They were up there a couple of weeks, right?
Seals go up there.
And seals go up there too. Okay. Okay, so we look at these guys by boat. So this is John Stern, this professor of sensitive state who's working with us, and he's taking this picture, and that's that picture he took of this cow, where the calf came right by the boat. His engines are off, and he's just idling out in the gate, and these guys Now, that's very different from what we were seeing in the 1980s, and we think there may be some behavioral differences with these guys when they come inside this narrow 1-mile gate. Maybe there's so much noise that they just sort of give up a little bit, resign themselves to being in a noisy, boat-filled area, and they don't seem to be quite as stressed. They seem to be handled, boat traffic pretty well from what we've seen. And then, of course, we're doing a lot of our work from the Golden Gate Bridge. And that's been the most amazing aspect of our study, is finding out what a first-class wildlife observatory the Golden Gate Bridge has been. And we've been able to do photo ID work from the bridge because these guys, of course, don't know you're there. You're 220 feet up, and they're passing in and out as they're coming in and out with tides. And it's turned out to be an incredibly valuable platform. And I'll get into more of that in a minute. Okay, so here's the things we're looking for on these guys. What was not known was whether you could really tell apart these guys. And in other parts of the world where they studied them, like in Europe, where they've got tons of studies on them because many of them are getting caught in fishing nets and fishing weirs. So they have lots of dead bodies to study them. They know the biology from an anatomical point, inside and out. But it's the behavior they have not been able to get a handle on. And so the way to do that is to individually identify them. And it's without tagging them, the best way to do it is just do photo ID. And if you can figure out that this pattern, if we see this again, is unique, it's like a fingerprint, then we can follow this mother with her, this is her neonate, which is all black. And so here's one with, we see some of these really interesting head patterns with these sort of white faces, and then some interesting patterns. So we're looking at pigmentation as one of the main characteristics or marks we use for photo ID. And of course there's huge color variation from dark to light, and it's really extreme because we found this really kind of rare one, this anomalously white one. We've seen it 3 times, and it can be a real marker. I mean, if you go out and you see this thing, you'll know it because you can see it glowing underwater before it even gets near the surface. It's pretty amazing. We've just written a little scientific research paper. It'll be coming out next week in a journal, Jane. So that was kind of fun to find this guy. Really beautiful. Even the scars on these guys are usually white against a dark background, but you can see here, look at this, it's reversed. Here is a dark scar against a white body. Very, very odd. There's been 5 reports in the last 100 years of white harbor porpoise. This is only like the 6th one. Okay, so now the other thing, of course, we're doing is we're looking at scars and scratches, marks on these guys. So here we saw this one going under the Golden Gate Bridge in May 2010. A few months later, sure enough, I mean, it's the same animal. It's not that hard to tell these two when you've got a really good scar scratch. And we've seen this one last month. So that's a year and a half later. And the scar is still there. So one of the things we're looking at is whether these scars evolve or fade. How reliable are these marks over time is really important to be able to track over time and estimate populations. So here's another example. Here's an animal. I'm glad this is like somebody came in and just gave it a check mark for us. This one is in our catalog. San Francisco Bay number 167. Our catalog is now up to 250 animals, and we're going to be at 300 here pretty soon. But we saw this guy from the boat, and then the next month, going underneath Golden Gate Bridge. So, and you can even see these other little fin marks, which I really don't know what causes some of these marks. We've shown these photos to scientists from different parts of the world, and it's a puzzle. It could be they see some of these kinds of markings on bottlenose dolphins that get curious, and they'll go down to a wreck, and there might be some wire or some weird stuff hanging off the edge, and they scrape themselves. But we don't really know. It doesn't really look like it's conspecific interactions where they're fighting or tussling or having any kind of, play or anything with their own species, because their teeth just wouldn't make these kinds of marks. So it's a little mysterious. It's one of the things we really want to work on. Okay, so here's where we're seeing them, the bigger numbers. Anyway, and if you want to go try to find these guys, this is how to do it. So Caballo Point, And this is Yellow Bluff right here. There's an ebb tide feeding spot there. And then the bigger numbers you'll see from the Golden Gate Bridge itself. And since the pedestrian side is on the east side, the bay side, then what you want to do is go out right at a big high tide and watch as the ebb tide turns, and you'll get lots of animals coming back towards the bridge. And when I say a lot of animals, I'm talking about in the last 6 months we've been counting up to 100 in 2 hours going underneath you. So this is actually kind of a big change for the bay when you think about the biomass of this is a big marine predator that is back in the bay. And they're eating small schooling fish, which is all they eat with squid. And so they're taking something out of the bay. There's no doubt they're having some kind of effect. Whether we'll ever be able to figure it out or quantify it, I don't know. But
Harbor seals feed on the backside of the pilings when the current changes. Do you see that with harbor porpoise?
I have seen it a couple of times, but mostly not. And but I have seen the harbor seals feeding really close to where the harbor porpoises are feeding, right near each other. And amazingly, they have a really similar style. I didn't really realize this until I looked at harbor seals feeding. But what these guys do, they'll see bait fish or something in the water, and then they'll just go crazy. They just start spinning around and running around after them, and that will attract gulls. And that's the thing I wanted to mention, is that when you go out here, the first thing to look for is find the gulls that are like dancing around on top of the water. What they're often doing is trying to follow either a harbor seal that's feeding or a harbor porpoise that's feeding. So you can key in because they'll have a better eye on it than you do. But these are the two spots. So what these spots represent are the areas where the shelf falls off deeply into this trench that's 300 feet deep underneath the Golden Gate Bridge. So I often walk all the way across, maybe more than once in a couple of hours, but you're pretty much guaranteed to see them if you pay attention while you're going across the bridge just after a big high tide. And hopefully, you can see there's no fog. That's the only other thing that stops our research is fog. So I just want to give you an indication of some of the lengths of time we're seeing these guys. So here's SFB number 3 that we saw in 2009 in September, and here it shows up a year and 5 months later. And a lot of these, maybe a week or 2 apart, but there's months, and we'll see them multiple times here too. Here's one seen 6 times. This is a female with a calf, so we would like to be able to follow her and see how often they gave birth to calves. So we're seeing lots only once, and several of them are regulars that are obviously using the bay repeatedly. Here's some of the other things that we're looking at. So anthropogenic impacts, human-caused impacts on these guys. This looks a lot. This is the same animal, like some kind of maybe a net scar or something. And so here's September 10, here's December 11. So I took this picture last month. And obviously got very heavily scarred here from being caught by something. But this is a female, again, we've seen with calves. So hopefully we'll be able to follow her over time because she's used the bait. We've seen her 6 times. Here's the other kind of thing. So obviously this is getting caught in some kind of a fishing line or cable or something that's linear and wrapping around the body. This looks, I showed this to a lot of people, including people who study manatees, because the big way to identify manatees is through their prop scars. And they say, yep, this looks like this curved prop scar on top of this. This is another female, a different female seen 6 times in the bay. So hopefully we can follow her too. Shark bite. I showed this to Scott Anderson, who's doing work on great white sharks out here. He goes, yeah, this is missing. Oops, there we go. This is missing a chunk of its flesh right there. And yet we've seen this animal multiple times doing fine. These guys are tough, really tough animals here. Yeah. We're also really looking at and wondering about their health. And we see pox, lesions, and we're not quite sure exactly what these scars are from these different lesions. We're going to be working with some folks who are doing cetacean skin work and disease and try and figure some of this stuff out. But we're not coming up in these with big numbers, but still several animals have these kinds of lesions or pock marks. And then there's marine debris issues, of course, that we're concerned about. And then, what I really am concerned about is someday we're going to get another spill here. Now, this area that I was talking about, Cavallo Point, and here, Yellow Bluff down here, this is where this ebb tide feeding spot is, where the water is rushing out and creates standing waves here, and the porpoise will come in small numbers and feed in here. So this is showing you the oil from the Casco Busan spilled a few years ago. And there's a lot of boat interactions with these porpoises, but they seem to manage to evade things okay. They just usually take an extra deep breath, move aside when a boat comes through. And of course, we're concerned about the America's Cup race, because not so much the racing boats themselves, but these areas are where the spectator boats may end up being. And when I mean spectator boats, I would imagine there's going to be hundreds and hundreds of them packed in there. And that area, that's Cavallo Point and Yellow Bluff and all that. So that's right there where a lot of these spectator boats are going to be. So that's one thing that Bill Merkel wanted to get information from us about. So he can, put in his comments about whether there needs to be mitigation or whatever for the America's Cup race coming up. So we're going to keep a real close eye on that and hopefully do some during on-race monitoring of the porpoises as it occurs. So we'll see. So now I want to take you on a little different view. That was sort of a view of photo identifying some of these animals and seeing the marks. But these guys live in a three-dimensional world, and so what we're seeing, if you stand on the Golden Gate Bridge, here's Cavallo Point towards the bridge, is these tidal rips that set up, and they can be on the ebb tide or flood tide, and this is where a lot of them feed right in here because it's churning up the water up in this little local upwelling, and it's bringing fish up. Presumably it's easier for them if it concentrates the fish right in that area. Then this is what it looks like from sort of their sonar point of view, and it's really a deep chasm right here underneath the Golden Bridge. This is the Marin side in San Francisco, so we're right sitting here somewhere. And here's these two shelves that you fall off, and that's where a lot of the tidal rips and a lot of the sightings are. But there's also this really interesting feature here. This is called the Cavallo Spire, and it's part of the ridge that runs down from Cavallo Point and continues underwater. So it's 300 feet deep here. Well, it's 70 feet deep right there. So there's this little spur that comes up, and when water flows in at strength on a flood tide through the Golden Gate, it smacks into that spire and goes straight up, and it creates a boil there. And they also feed around that boil. And those boils you can see them during the flood tide, but at other times during ebb tide you won't see it or notice it at all.
Do you know what the composition of that spire?
And it's the same rock. It's the same exact rock. It's just a continuation of the hills coming up behind Fort Baker.
I think it was higher, but I think it was broken off to allow ships.
Yeah, they could have had some dynamiting of that a long time ago. They've still done that in the 20th century, I know, around Alcatraz and some other spots, Green Bay Rock and stuff.
And is the rest mostly sand?
Right, we can go back. So this, in fact, these are sand dunes, very large sand dunes, and there's sand dunes out here too. And there's sand mining that goes on still to this day in San Francisco Bay off Angel Island. So these big sort of dredges come with these big suctions, and they suck up the sand. That sand is actually replenished by bringing in big sandy areas off San Francisco. It comes back and moves back into the bay with strong flood tides. Okay, so what do we see these guys doing behaviorally? This is really the new stuff, because there's nowhere in the world they've been able to figure out and look at porpoise behavior until we sort of figured out all the stuff going on the bridge. But we see them riding the wakes of ships. They won't go to the bow, but they will, follow behind. We see a lot of really interesting seabird interactions. So these seabirds, like I said, the gulls, it's more than just gulls, but they can watch them underwater. So this is me watching a gull, watching the porpoise from the Golden Gate Bridge. And notice it's turning on its side a little bit here. That you can see the flipper. That's because it's going to start to go into a little feeding sideways spin. So here is a cormorant that's diving underwater to follow this guy around like a little jet fighters, zooming around underwater to get scraps off these guys. And I think for these gulls, it's more a matter of not getting scraps. Because I don't think these guys leave a lot of scraps. They mostly don't even hardly use their teeth to bite. They catch the little bait fish, little sardine or herring, and they might use their teeth to kind of catch it at first, but then they just basically suck it down. They're just swallowing it. And so what I think is really going on is that these porpoises are driving bait fish and trapping them up near the surface where the gulls can easily get at them. Here's feeding what it looks like. So you'll see them turn right on their side and just spin. So this is like 3 shots of the same animal over a second, just zooming around underwater, spinning. Okay, so we're seeing social activities, groups. Here's a calf with its mother right here. Particularly in the fall, they group up. They're often just in 2s and 3s or solitary mostly, but in the fall, we'll see quite a bit of group activity. And what's nice about the Golden Gate Bridge and the San Francisco Bay is that these guys are here all year long, 365 days a year. So in most areas of the world, when they study them, they're migrating somewhere else, or the winter they're not there. It's too harsh of weather to deal with them. Here, one of the rare areas where you can study them all year long. We're spending a lot of time looking at mothers with their calves because on the East Coast, there was a famous paper written several years ago by a guy named Andy Reid called Life in the Fast Lane. And it's about harbor porpoise lifestyle. Because when you think about it, if you live to 10 or 12 years old, that's it. Let's say you start reproducing when you're 3, maybe. So you've only got 7 to 10 years of reproductive life. And if you have a calf every other year, that's not a lot. In the East Coast, they found that they give birth every single year. And so that means the adults, once the females are, say, 3 years old, they're pregnant and then lactating for the rest of their life. And that's an amazing amount of energy that has to go into, raising their calves and reproducing. Most mammals aren't anywhere close to that. Most cetaceans aren't. So these guys really are the speedy life in the fast lane guys, even for cetaceans. And on the California coast, there was one study done in the it was published in 1990, it was done in the 80s when there was the bad old days when we had lots of gill netting off our coast, and there was lots of porpoises being washed up, so we had lots of dead bodies to look at that time. And they looked to figure out which females of these 32 that they had in the series were pregnant and lactating, and the answer was none. So they figured, well, that must mean they have a birth every other year. And that means that's a really low amount of calves you can turn out in a single lifetime for these animals. So we wanted to see, by looking at these guys, whether that's true or not. And we're already finding out that it's mixed. In other words, these guys are flexible. And if there's lots of food and there's a lot of resources and times are good, they'll have a calf every year. We've at least seen a couple of animals that showed up with a calf in a year. And we have some evidence that there's a rest year for some females. So it's probably a mixed bag, which is, biology is always more complicated than you think. It's not one or the other. It's somewhere in between. So their gestation period's 10 and a half months. And they nurse them all the way until, so if they'll be born in June or July, then they'll be, when the next calf comes along is when they'll nurse. Or if they don't have a calf, they have a rest year, they'll still nurse them about maybe 10 months.
What do you think that calf is?
This calf, we will know, because it was October is when I took this photo, so it was probably born in June or maybe July. So this calf is whatever, 3 or 4 months old. And they will stick pretty close to their mom for those first few months, and then they get more and more independent as they grow up over time. So then what we got into is, yeah, question in the back.
Question is, if they have them cast every year, what's the life cycle for these guys?
The lifespan?
Lifespan, yeah.
The lifespan is 10 to 12 years. Very, very short. So that's why there's not a lot of time for them to have calves.
And that's for the ones that are having cast every year
Correct.
versus the ones that are every 2 years. Huh?
It makes no difference. Their lifespan's the same, they found. Yeah. In other words, they don't get, maybe they get a couple extra years if they rest, but I don't know that. I mean, all we know is that the problem is, of course, we can't ask them their age, so what they do to age these guys is there's two different ways. The main way is to look and section their teeth, and their teeth can be like growth rings on a tree, so they can count these growth layer groups in the tooth and estimate their age, and that's how they know that most of them are 10, 12 years old, at least when they, in terms of the sort of peak numbers or how long they live, and then a few will go out to 20 or 22 or something like that, but very rarely. They also can look at inside at the female's ovaries, and they'll leave scars where they've had pregnancies before, so they can estimate the number of pregnancies they've had. So those are the two ways they can do it. So then what happened is we started looking at females, and then we were kind of looking at this other behavior, which has never been reported, which we thought was courtship. And so, and here we finally started seeing that this is it's not really a penis or an erection, but it just shows you where the penis would come out of in a male. And he's sort of like zooming up from underwear. This is very fast. This is happening all in a split second, but he's zooming up underneath this other animal on her left side here. And then we saw other ones doing it. Here, the same thing's happening again, zooming sort of straight up along the side. And here, we remember that animal with the check mark I showed you earlier? Well, this is what we now presume is a male coming up and trying to mate with her. So now we have potentially, we can figure out her sex. Okay, so this is the one photo that kind of started us really rethinking harbor porpoise behavior and its sex life, which has never been reported. No one has ever seen a mating harbor porpoise ever in the world, which is kind of amazing when you think about it. All these other mammals, land mammals are easy and cetaceans are really hard. No one has still seen, with thousands of tourists going out to Hawaii, humpback whales actually mating. It's incredible. But I took this picture, this was a couple years ago now, and then when you blow it up, you see this, and you go, what? That's his penis. And it's incredible. And so, no, people didn't know. I mean, in other words, you could cut open a dead one and see it's a pretty sizable penis in there, but they had no idea when they were, in their courtship, and they were flying out of the water with these, this is like 18 inches long. So that's a third of their body length. And so what's going on with these guys? Well, one of the other things that's happening with harbor porpoise, why they're so unusual, even in cetaceans, is they've got these massive testes that grow up every single year. So the testes are, I don't know, tennis ball size or whatever during much of the year. And then they get a huge shot of, the males get this big influx of hormones, this testosterone, in the spring, and the testes grow up and they're huge. They get, each one is this big, it's like, they get to weigh like 4% of their body weight. So it's bigger than their brains, and you've got, I mean, that's what's going to happen, is they're going to be very interested in mating. And there is theories that were done in the 90s, there was written about in the 1990s, saying, well, these guys must be reproducing through what's called sperm competition. That is, the males are actually slightly smaller than the females. We have seen zero aggressive interactions between males. Now, we don't know what's going on sonically. Maybe they're using their biosonar to, harass another animal or something. But in terms of physical, we haven't seen any. That's expected in this species. But what could be going on is that they are competing by having more and more sperm so that it can just sort of engulf the other competitor's sperm in a female's reproductive tract. That's the theory anyway.
Are the
So,
testes internal?
pardon me?
Are the testes internal?
The testes are internal, exactly. And so that keeps the whole body, all cetaceans are like that. And so it keeps their outer form very hydrodynamic so they can slip through the water. And the penis is all inside, and then it's not a penis, well, I don't know if I want to get into all the kinds of penises that are in the world, but they can put it out and bring it back instantaneously at will. So here's another mating sequence here, right underneath the Golden Gate Bridge, and they're actually, it's hard to see it, but I think this is one of the 2 times we've seen actual copulation, actual intermission, where the females usually just keep traveling when all this sexual activity is happening, where these males are rushing at them, but here she's kind of slowed down and kind of rolled onto her side. And then a split second later, he is driving so hard into her, he flies into the air, and that is the tip of his penis, which originates back here. So this is completely unknown behavior for the species. So when I was at the Marine Mammal Conference recently in Tampa, it's every other year they've got a big international Marine Mammal Conference, and the guys who study these guys, like Andy Reid and stuff, who wrote the paper I mentioned earlier, Life in the Fastland, he said, I spent thousands of hours looking at these guys, mostly in Canada and off of Maine, and he said, I've never seen them mating, ever, and we had no idea about this kind of behavior. So this is like original research going on right here in San Francisco. And of course, they all laugh at this because it's about sex in San Francisco. Of course, that's where you're going to have everything hanging out in these places. But so here's another sequence of a couple where this male is going to fly out of the water, and it's very hard to see his penis there. But in the next shot, yeah, so these guys are rushing frequently at these. Presumably it's a female, but we don't know. And there has been homosexual activity seen in dolphins, so we don't really know, but certainly we assume that's the general case. And they're doing this a lot. And so...
is your guess that was a successful thrust or is a miss?
No, I think this is an attempt.
Okay.
But here's the thing we don't... remember that reproduction and courtship is complicated. For all I know, this could be part of a regular pattern where they do this 3 times just to see if the female's receptive. You don't know what's really going on here. And we don't know if this is a young male that is, it's just trying things out. You don't know whether this is a reproductive female or not. We don't know. In fact, one of the big mysteries in cetaceans is how do males know that the females are in estrus, whether they're reproductively ready. And in land mammals, I got to step back one more step. Evolutionarily, all these guys came from artiodactyls. They're all sort of from a ruminant kind of background. And so when you think about cows or deer or antelopes that are mating, the males figured out because their scents from the female's urine, usually. And so it's not that hard for them to figure it out. How do these guys do it? They probably don't have a great sense of smell. That's probably not what they're using. So it may be a visual thing, or maybe there's some behavioral thing. We don't know. But this is all why cetaceans are still so mysterious and unknown. And here's the other thing. Did you notice, going back through these things, that the male was always, and we've seen this behavior 32 times, always on her left side, never on her right. Now that's very odd. Dolphins they see mating, and they'll just come whatever side. So that's a whole nother area of inquiry we've had to go down, is figure out why would it be. And there's 2 possible answers. One is that they know that there's a pelvis bone inside these guys, right? They came from land animals, so their pelvis is reduced to a tiny little chip of bone that's actually inside their body. The males are bigger than the females, and they think that's because the bone that's floating in there is the attachment point for the penis in the male, so they need a stronger attachment point. And one of the things we're looking at is whether the attachment is stronger on one side or the other, whether they're sort of handed or lateralized in their penis. But the other answer could be simply it's their biosonar, that they're the way their heads are anatomically, there's a little bit of asymmetry in their head, and that could help them, just the way owls might hear asymmetrically. Their ears are offset. Well, these guys, biosonar may be offset a little, so they have a better side than the other. And when it counts, well, in terms of reproduction, they want to be hyper accurate in terms of an approach. Maybe they just always favor their right side, the female's left when they're approaching. And these are another mystery that we'll have to look at. Okay, so here's a picture of a mother with a calf, this really young calf. We've never seen a birth. That would be like the highlight of all time, is to be able to be there present for a birth. But they're bringing incredibly young animals with floppy little dorsal fins underneath the Golden Gate Bridge. So that's the other thing to look at is San Francisco Bay a preferred calving area, a resting area or protected area that mothers know that that it's not as surgy or is difficult out in the ocean, and they can bring their calves inside for some rest. We don't know, but we'd like to look at that. Okay, so let's talk about the other fin that's happening out in the bay. So here's a picture I took off Fort Point, because we're seeing bottlenose dolphins coming in regularly in the fall, summer and fall, into San Francisco Bay. And so here's what's interesting about these guys is that there is about 500 is the latest one. This says 400 from the National Fisheries, but I talked to the researchers, and I think it's more like 500 individuals off our coast, compared to, I don't know, off the California coast, there's probably 50,000 harbor porpoises and 500 bottlenose dolphins. And every one of these guys, or at least every adult, is known. They're all identified and tracked, probably from when they started in Los Angeles and San Diego. So what's happened is, before 1982, there were no bottlenose dolphins along our coast. 1982 was a big El Nino year. Water warmed up, and these guys came from Point Conception all the way into Monterey Bay, and they didn't go back. When the water went back to normal temperature, they stayed, and they've learned to kind of make a living here. They've learned the habitat. And now they're regularly seen off Sonoma. This is actually the National Marine Fisheries Service map, but it actually needs to be extended because their normal range now is San Francisco and Ocean Beach, where you can see them regularly.
And last year they were seen in Tomales Bay.
Right, Tomales Bay. And I've seen like one once up in Drapes Bay, so we know they're crossing and getting up there in small numbers. But in terms of sort of regular numbers, they're definitely turning the corner, coming into San Francisco Bay, and you can see them at Fort Point. A few times they've been seen further in, like there was a report 2 years ago, there was 3 of them in Redwood City in the harbor. So they will keep going once in a while. But it's so different studying these guys because they're all known individuals. So here is at least the adults. So this adult is a well-known one. That's an adult female with a mother with her calf. And this calf, you see these little vertical lines in it? These are called fetal folds. So when the fetus was inside the mother, it's sort of accordioned up or in a U shape. So when they come out, they get these stretch marks that'll last for a few months. And it's called a fetal fold. And they'll fade in a few months. So this is an animal that's not cataloged because it's so new, but the mother and aunt here are definitely known. And what are they doing?
What was the name of that shape?
Falcate or curved dorsal fin, or falcate dorsal fin. So we know they're feeding, and again, and this is amazing. I showed this to researchers who are studying these guys in Monterey Bay and other places. They've never had a picture of these guys. They didn't know exactly what they're feeding on. But here, you're standing. I'm standing on land taking this picture. I'm standing at Fort Point. This is going 50 feet, 100 feet off the shore. So it's a pretty amazing sight to be able to go down. This is September, and they came back, and they were here August, September, October, also last year. So here's the same map as before with the porpoises in blue, but here's the dolphins will just work. They'll stay very shallow. They'll stay inshore of where the porpoises are. So the porpoises will actually be deeper than the dolphins. So Crissy Field's a good area. Okay, here's that same ant. So again, it's nice because you can take a picture from either side and identify her. And she's been seen since '82. So I mean, that's amazing to think of. And they think she was 10 years old, at least back in '82 from her scars. So born in 72, so she's 40 years old. So, and these females can live to 50 years old, maybe even longer. So it's pretty amazing. So what we do is we take pictures of them, and we immediately share those photos with the crew that's doing the work in Monterey Bay, because it's mostly these Monterey Bay ones. And now we've seen the travel time between San Francisco Bay and Monterey Bay is 2 days. Now, it could be less, but we've seen them in 48 hours be all the way into Monterey Bay, the same animals. Okay, so there's been some talk about this in the papers recently, and I just wanted to touch on this so you know the facts. There's been talk of porpoiside, and that's actually the actual title of the paper, scientific paper that just came out a week ago in Marine Mammal Science, describing this interaction, this deadly interaction sometimes between the much bigger bottlenose dolphins with the much smaller Shire porpoises. So a couple of years ago, in 2009, one of the researchers in Monterey Bay took this picture, and this animal ended up dying. This was a fatal attack. They saw it happen. They videotaped it. They know what's going on. They've seen it a couple of times. They know the 5 or so individual male dolphins that are responsible. They sent us their little mug shots. Well, I mean, we're interested to know if they come up here, if anything happens. In the bay, we have seen no interactions with dolphins and porpoises. We've seen them ignore each other 100 yards apart. There'll be some dolphins. But again, most of the dolphins coming into San Francisco Bay that we've seen are mostly females with calves. There are some males coming in, and there'll be maybe porpoises working a tidal rip 100 yards away, and they just ignore each other. We'll see if that changes. We have had some evidence that there is this porpoiside of this lethal aggression on our coast, because in August of this last year, an animal washed up, porpoise washed up dead on Ocean Beach, and we sent it to the California Academy of Sciences, who was the first ones on the scene. They picked it up and sent it to a physician who did a CAT scan. And there was almost every rib on the left side was broken, almost every rib on the right side was broken. Both mandibles, both lower jawbones were shattered, and the scapula on one side was shattered. That is exactly the kind of blunt trauma that they see with these killings of these porpoises by the dolphins. If you have a ship strike, it would tend to be one-sided. But this lateral breaks on both sides and all these contusions, internal damage, looks like it was dolphin caused. So we know it could be happening in small numbers here. And then there was Alvaro Jaramillo, a naturalist in Half Moon Bay, believes he saw an incident. He didn't have any photographs, but he described exactly this kind of thing where they were even tossing the animal into the air. So then it gets into, well, why? Why would they be doing this? So the researchers in Monterey think that their best guess is that they know it's just males doing it. So they think it has something to do with sexual frustration and a lot of excess sort of testosterone, or not excess, but they've got a lot of testosterone. They don't have access to females. And they're sort of taking it out on an easy target. But there's another aspect of it that could be at play here, and that is that dolphins have been known, they're not common, but it certainly happens, to commit infanticide. And lions do it and other mammals do it because when they come into lions, certainly in the pride, will do it because they want the female to raise their own offspring, not some other males. So that it's possible that this is kind of practiced infanticide, this theory goes. And they've described this in this paper that came out last week. But no one really knows, of course. These are just conjectures. But I want to at least give you the facts. This is a not a common thing. It doesn't happen all the time. But it makes sense that it happens wherever dolphins and porpoises come together. They've seen it in Scotland, and they've seen it in small numbers on the East Coast. So
A similar sort of interaction occurs between elephant seals and harbor seals.
between, say it again?
Elephant seals and harbor seals, where young male elephant seals kill harbor seals.
Huh. Okay, that's interesting.
Now, in the case of the porpoise that was CAT scanned, would that internal damage be in addition to like teeth marks? I mean,
Yes, there are teeth marks that are left on them because they will another thing, another part of their thinking that this has something to do with this sexual tension. But not everyone that they've seen has had bite marks. So it's sort of mixed. I mean, I saw the pictures of this animal that was, and it had some marks on it, but then, of course, it was sitting on a beach and gulls were picking at it, and you know, it gets a little hard to say sometimes. But yeah, it's a pretty interesting behavior. But again, I don't think it's gonna, you know, it's not like the dolphins are coming in. Because there was an article in the paper. It was in the Bay Citizen, but it said, you know, like gangs of, you know, dolphins are wiping out our porpoises and all this stuff. It's just not the case, not even close. But anyway, so that's our basically our research here. So any questions? Yeah.
So do they, what a night-day activity?
Good question. We would love to know more about their night-day activity, and the way we're really going to get at that is through listening. We're going to try to put down some hydrophones at some point. They can detect the clicks of the porpoises, and we'll know if they're there. They do this commonly in Europe, where let's say they're putting up a wind farm off Denmark. They want to know how many porpoises are there. They don't even bother going out in boats because they know they'll just leave. So they just put up these porpoise detectors, these little hydrophones on the bottom. It's a little chip like in your camera, and it sits in a little plastic tube. After 2 months, you take the chip off, put it in your computer, and it reads out all the times there were porpoise clicks there. At least that's in theory, of course. Every time a boat goes by, you lose that. You know, and it's very noisy here in the bay, so it's going to be tricky for us to do that, but I think that's something we'll definitely do. I've seen them very late in the day, like feeding to sunset, so I don't presume they're all just leaving because it's nighttime. I presume they hang out here in the bay too. We just don't know that yet.
Do they go to sea though?
Well, you know, that's another tricky thing. I would still love, even though we can get photo IDs, I would still love to be able to radio tag an animal one day just to go know some patterns in and out of the bay. If you're seeing, you know, 100 animals in 2 hours leave the underneath the gate, I presume they're going out into the ocean. I have had an animal wash up dead this summer, also on Ocean Beach, and that was a known female from our catalog. So she was in the bay, and then she was out of the bay. I presume this is all just their habitat, and it's not so restricted that they've got guys only living in San Francisco Bay, you know, only in the ocean. I think they're mixing back and forth, and that's why we're seeing hundreds in these photo IDs, because they're just recruiting members, or there are other ones that are just following ones. And for instance, that white one that's so easy to see, we'd see it every single time if we went out. Well, we've only seen it 3 times over, 8 or 9 months. And I presume that's because a lot of the time it's just out in the ocean and no one's seeing it.
Yeah, I was curious if there's any information for either a harbor porpoise or a dolphin, maybe from tagging data or otherwise, about like an individual's range.
Yes.
And sort of site fidelity and whether
Well,
they
here,
stay.
site fidelity is tricky because it's different in different parts of the world. They have radio tagged some animals on the East Coast, and it was released in Maine, okay, and it went 1,000 miles south.
Is this a harbor porpoise or a...
Harbor porpoise, yeah. These guys can move around out there in the ocean, yeah, if it wants to. Now, I'll bet you we don't have a big migration because we don't have the extremes of temperatures and weather and food changes that they see in, you know, colder areas. So it's a good question. I'll bet you ours are not particularly migratory from the numbers we're seeing, but on the other hand, we don't know an individual's home range right now along our coast. That's what you really need to do, kind of tagging studies to figure that one out. Any other questions?
Well, about a month ago, I came upon a dead humpback at Alamere Falls, so sort of isolated at Point Reyes.
I heard about it.
Oh, you did? Okay. So I'm just curious there's no way for, other than going and checking it out, documenting it, it's just going to stay there, I assume, and rot.
Is that the Mickey?
It's a Mickey.
Whale?
There's a Mickey.
Was it a Mickey? It
Yes.
had the
Yeah, it was
It was a Mickey.
collected, it was collected by California.
Right.
oh, really?
Yes.
So it's by boat?
No, by land,
Really?
yes. You can ride out to Wildcat campground and then you got
pretty valuable, and you don't get minkies coming out very often. But yeah, once, I mean, sure, there's animals that if you can't get at them, they'll, I mean, that's what happens, I guess. There was a question in the back there? Yeah?
Yeah, you touched on it a little bit. I was just wondering what degree of radio telemetry there is for cetaceans and how that would work.
Wait, it's a degree of what?
Radio telemetry?
Oh, well, exactly. I mean, you're really, interfering and harassing an animal to a great degree when you're doing that. Now, one of the tricky things with these guys is that they're so small, it's just really hard to get something on them. Now, if you capture them and bring them up land, then you can drill holes into their dorsal fin and put a little radio tag on. They're about not much, a little bit bigger than this thing. But what the better way to do it is that they're trying to invent a small suction cup. Now, they work this out for bigger animals like humpbacks and blue whales. They'll take a pole that's like 15 feet long. They'll get up alongside the animal and they'll smack this little radio transmitter. It has a suction cup on it. It just sticks to the animal. So at least it'll hang on for a while. And that's much less invasive than drilling holes into its dorsal fin. And I really, I think we would do that maybe once if we happen to get an animal that's live stranding. But I don't think we're going to just run out there in a boat and try to. Getting one of these guys would be actually quite an operation. We'd have to have nets, and it would be a big thing. And so we'd have to go through a public comment period, get a permit to do that in this area. So that's going to be a whole, that'd be a big effort. I think they're going to, the first place they probably try that on our coast is Monterey Bay. But because I know that the National Fisheries Service is interested in doing it. They have the same questions. How big is a home range? Are these guys moving in and out? What's going on with these guys? But no one's done it on our coast yet. So they've done it on the East Coast. And like I said, they move quite a bit. Yeah?
Are these guys pretty active as far as like jumping out of the water?
No. The only time we've ever seen them jumping out of the water is the courtship that I showed you. That was it. They've never been known to, and that's why they were so stunned. Very unacrobatic. And usually they just sort of roll at the surface and they're kind of boring in that sense. They see a lot of that kind of behavior. But if you look at it long enough, you're going to see some of this different aerial behavior, which seems to be a part of that mating cycle.
Yeah, I'm just wondering because I saw some very small animals off the coast at Radio Beach.
Yeah, that's probably them.